Alright, we're nearing the end of part 1. For this section, we're going to be talking about processes and process management. Our objective is to understand how we can manage and control processes. So what's a process? A process is a running instance of a command. So whenever you run any command on Linux or on Windows or on any operating system for that matter, there is something that's created that's called a process that will be attached to this command. So let's say, for example, I fire up my web browser. The moment the web browser starts, a process will be started with the web browser and for the web browser. If I start a media player, another process will get started for the media player. If I start the ping program, another process will be started for the ping program. So they're just instances or running instances of a certain command or a certain program. And these processes can be viewed, can be paused, can be stopped, can be put in a background, and you can bring them back to the foreground after you put them in a background. We'll see what all that means in a second. Before we do that, we need to know that every process in Linux has a unique ID. And every process is also associated with a user and with a group. So if I start a process as the user root, that process will be associated to me as root. If another user called Tom starts a process, that process will be associated with the user Tom, and both processes will have different IDs. Now obviously, processes that are run by root will have more access rights and will have the possibility to access more resources on the system. Now, the important thing to note here is that if I start a process as root, my process or my program will have higher privileges and will have more access rights to the system and to the resources on my system. And this is why in Linux and in Windows, it's recommended that you never run anything as root. Especially if you're downloading something from an unknown source. Let's say you go to a website, you click on something, it downloads, and you want to see what it does, you try to run it. This is dangerous because if you're running as root or as administrator on Windows and you execute this, it will execute in full privileges and will have access to any resource it wants on your system. This is why it's recommended you log in as a low privileged user. And whenever you want to execute a program, or let's say you want to install a program, you can do that as an administrator temporarily and then go back to the regular user once you're done. Which brings us to the post-exploitation tip for this section. After you compromise a host, you want to find the processes and the programs that are running by root. And you want to see if any of these programs suffer from any security issues. If they are being run by root and they have any security issues that you're able to exploit, you will be exploiting them and getting access to the system as root. Here are some commands that we use when we're managing processes. PS list processes of a current session. So if you're logged in, you type PS, you'll see all the processes that are running in your session. PS-F will list the processes in full formatting. So the output will be fully formatted and will look different. PS-E will list every single process. PS-U and a username will list processes of the particular username that you define. And PS-P followed by the process ID will display information about that particular process ID. Let's see how that looks like. I'm logged in now as root and I type PS. I see two processes running, the bash and the PS. Bash is my shell prompt, which I'm currently using, and PS was the process that I just launched. Let me try the PS-F and see the difference. Now, in addition to the previous output, the important piece of information here to look at is the additional UID column. This now is telling me which user is running what process. That's valuable information for me. Let me try the PS-E. And you can see now that the output is completely different. There's a lot more processes that I can see, including an SSH daemon that's running in the background. So here is not only showing me what the user is running, but every single process that the system is running as well. Let's see what happens if we combine both the E and the F. PS minus EF will give me a much more elaborate output with a lot more detail. Look at that, for example. I can see exactly the program that's running, including the options that it was running with. It's a very long list of processes on the system running. So I want to see what processes are being run by root only. And to do that, I do PS minus U root. And here I can see all the processes that are being run by root. If I try another user, let's say Tom, for example, and I do PS minus U Tom, there are no current processes being run by Tom. Let me see if I can change that. I'm grabbing PuTTY and I'm logging in remotely as Tom. I'll change the settings here and make the font a bit bigger so you guys can see clearly. And now if I try the command again, PS minus U Tom, look at the difference. See all the new processes that appear, notably the SSHD because I'm connected over SSH as Tom, and the bash because I'm logged in into my shell as Tom. Now, of course, as Tom, I can also see the processes that are being run by root using the same command, PS minus U root. And I can see all the processes that are being run in the root context. Let's try to run the ping program, and I'm going to do ping hackersacademy.com. And I go back to my other shell. Now if I do PS minus U Tom again, look at that. The ping command appears in my process list. Let's say I want to kill a process, so I want to terminate a program. Maybe the program is hanging, it's stuck, it's not responding anymore, or maybe as root I see that Tom is connected and he's doing something that I don't want him to do. What can I do to do that? I use the kill command and follow the kill command with the process ID. So now if I want to kill the ping program, I type kill and 3113, which is the PID of ping. Obviously the ID changes from one system to another and from one instance to another. Now if I go back to Tom's shell, I can see that the ping command is dead. Another way to do that, but you need to be careful when you're using that, because that's a bit of a harsh way to terminate a program or a process, is to use the kill -9 option. Sometimes when you use the kill alone, there are certain processes that can be a bit stubborn and you will not be able to kill them. If there is no other way, you try everything and there's no other way to kill these processes, you can use the kill -9, which forcibly stops the process, regardless of what it's doing and what it's writing to and what it's interacting with. This might cause some damage to your system depending on what you're running at the time. So please be careful when you're using that. I'm just putting it there for the sake of completeness. So let me try that again. If I run the ping command again and I do the PS command to see the PID of ping, and I do kill -9 and the PID, this time notice that it's changed to 3125, and this kills the ping program. Now let's say I want to kick Tom completely out of his remote session. I can either kill the SSHD program or I can kill Tom's shell, which is the bash shell. And that has the PID of 3100. If I do that, kill 3100, and I go back to the PuTTY, it's not there anymore.